Good afternoon and welcome to Automotive EV. My name is Peter Wooding and thank you for joining us. We have a great session this afternoon looking at powertrain and general aspects within the EV market. I'm joined by Kevin Kelly from Frost & Sullivan, David Hudson from Tata, and Greg Ombach from Dräxlmaier. Greg, yeah?
Yep.
And the flow of the session will be Kevin will start, followed by David, who will give a short presentation, and then we'll go into the warm-up, I'll call it, from Greg, and then a general discussion. So thanks very much, and over to you, Kevin. Thank you.
Thank you very much. So hello to everybody out there who's sitting watching or watching on catch up. Obviously in these COVID times, this has now become the norm for our conferences. Gone are the days of us all meeting up together and having nice tea and coffee and cakes all day and watching many presentations. But that doesn't necessarily mean that the content or what we can discuss is going to be any different or any less important. So today I've got the great honor of moderating and controlling a little bit of this session on powertrain. As mentioned, my name's Kevin Kelly. I work for Frost & Sullivan, a growth consultancy company based basically everywhere in the world, but I work out of the London and European team. I head up the powertrain and EV consulting team, and basically that means I support clients throughout the entire automotive value chain and the entire automotive ecosystem, kind of understand how to grow when in these new business areas, whether that's battery electric vehicles, the battery supply chain, charging, or anything in between. Obviously today we're going to try and focus a little bit more on the powertrain thing, but because this is obviously automotive EV, we will definitely touch on some of these key EV questions. And one thing I always like to frame when it comes to powertrain, we are all, I think, here today, we're all very interested in EV. We're all interested in electrification. And I don't think any of us are saying that powertrain has to stay for X, Y, and Z reasons. But it really needs to come back to a little bit more of the relevance of the data and really an understanding of where we are in the situation. So I put together some statistics this morning just to show you where we are as an industry, where we're going to be sort of in the next 10 years, and just what size of challenge we have. And hopefully that will open up the questions later on to how we actually transform to be a zero emission or a low carbon automotive and economy as well. So this year to date, obviously is a very challenging year because of COVID, but this year to date, 16.2% of vehicles sold in Europe were electrified. So hybrid, mild hybrid, full hybrid, battery electric, and the small sort of numbers in the single digits near enough for fuel cell as well. Now that is up from 8.4% last year, so it's a doubling in the growth rate, or the doubling in the share that it's been able to achieve, mostly because of COVID, to be honest. But that still shows you that there's a massive gap even towards electrifying the sector. Now, if we take which ones had engines and really had a powertrain, a more dynamic powertrain over a battery electric vehicle, 96.3% of those cars sold to date this year, 96% of the customers driving around in new cars this year had an engine of some kind in it. Typically gasoline in the vast majority of them now in our sort of post-Dieselgate economy. So yes, we can really drive the electric agenda, but we're still seeing there's a large way to go. And today, hopefully, we'll have some discussion points on how do we accelerate that growth, but how can we also minimize the impact on some of these powertrain solutions. And if we take the forecast that my team does in Frost & Sullivan, we're estimating by 2030, there will still be 70% of vehicles will have engines in them. So this market is definitely declining, but not to the significant levels that you may want to see. Obviously, I mentioned COVID-19. COVID-19's done some amazing things of a silver lining, if you will, if you want to take the positive from all situations. COVID-19, as I've just said, with electric vehicles has really driven a massive share in growth. We've seen that during the COVID peaks in lockdown areas through March and April and May, that actually the EV sales were very strong and very robust, declining a very small amount. And this has also had an impact on the consumers who are looking at more green opportunities in terms of their next vehicle purchases. OEMs have announced massive shifts towards more electrified powertrains and futures, and they're trying to ramp up how many electric vehicles they want to get to market. And we've also seen governments in a post-COVID-19 say we want to return greener and better. So we have France and Germany who are kind of leading the way in this, with instigating through PSA and Renault, or in Germany through their funds as well, about bringing back economies in a greener, and our automotive in a greener fashion. So not just from electric and a battery electric side, but also from a general powertrain side. That means, what do we do about mild hybrid? What's the position that mild hybrid plays in the future? What about plug-in hybrid? Is plug-in hybrid the next Dieselgate? What about CAFE compliance? How are we actually going to implement this as an industry? And the other part as well that hopefully we'll talk about a little bit later on is we are very heavily here, focused on Europe and what's happening in Europe or what's happening in the UK. But what happens globally is critically important as well. OEMs work on a global stage, a multi-brand stage. So when we see here, okay, China's going battery electric, Europe's going battery electric, there's regulations and compliance there. But what happens in the US? How is the US going to perform? How do we decide which powertrains to go for? What about other markets such as India? Dave's, from Tata here. We've got excellent insights in not just what they do there, but also through obviously their other partnerships with other companies where they factor in globally. What about what we see in Japan, where Japan has really struggled to adopt any sort of electrification other than hybrid? How, as an OEM and as a consumer within this global environment, how do we make this move to electrification through evolutions in powertrain? So that's kind of what I wanted to start off today. Hopefully give everybody a little bit of food for thought. Please put forward all your questions and we'll try and work through those at the time. But with that, I'll pass over to Dave and let him do his part of his presentation, and Greg before we start off on the Q&A. So thank you very much, everyone, for joining today. Hopefully we'll have a really good and interesting discussions.
Okay, thanks very much, Kevin. Great introduction, of course, and you've covered everything, so we don't need to contribute anymore. So just by way of introduction, I'm Dave Hudson. I head the vehicle and powertrain engineering activities for Tata Motors European Technical Centre based in Warwick. We have a broad interest across some of the new mobility parts of the Tata Motors portfolio, and have been working for the last 10 or 12 years on EVs, but also looking at connected and autonomous and some of the other aspects of the cases, ACE, whatever the acronym you prefer to use is. So what I've got is a few slides which are actually building on some discussions we had back in May at the previous Automotive Live, EV Live sessions. So let me share my screen. Let's hope that the technology works for us. And we will move to a slide that's the wrong slide. Oh, there we go. So hopefully I'm live with a slide here. So the title I've put on here is Efficiency Matters. And so it's either the matters relating to efficiency or efficiency really does matter. If we go back 6 months now, the discussions we had in May, I presented some data about efficiency as part of the presentation there of how we were using EV powertrain to clean up the world, but also pointing out that there are quite a lot of open issues around about efficiency. And at that time, it was one of the quotes that had just come out was from Peter Rawlinson at Lucid, who was talking about how they prioritized efficiency. We've now seen the launch of the Lucid Air, and although they're still a little bit cagey on some of the final numbers, it's evident that they have achieved some pretty remarkable efficiency numbers in that car, partly by having a very, very low aerodynamic drag, but also I think some trickery in the powertrain, the e-powertrain side of things. And I put up another slide which talks about the important factors for drive units in the future and for efficiency, saying that we've really got to put some stretched targets in place to do that. In the meantime, I've been thinking about this, and one of the problems we have as automotive engineers is that we're pulled to some extent by our markets but our markets are also motivated by different forces that come to play in people's decision-making process. And historically, in matters of fuel economy or of emissions, even though we have customers who know that these things are, lower is better, we do our best work when we're driven by legislation. Now, in terms of efficiency, what incentives do we actually have to buy these better EVs? And what I've put up here is a graph of in the UK, the vehicle excise duty rate. So these are the annual costs of keeping an EV on the road. There's a slight split because there's a higher first-year payment typically. But what this shows is that on the right-hand side of the graph, you've got the very poor fuel efficiency vehicles where you pay a high annual fee to keep them on the road, and then it falls off, and below 100 grams per kilometre, there is zero excise duty. So the cars are effectively free to run every year. But this is a pretty blunt instrument in the way I would look at it, because once you've chosen a BEV, you're in this below 100 grams number, you're paying nothing, so it's all fine. And we see all those vehicles as having the same merit. But my question, and it's perhaps one that will spur legislators on to do things we'll regret later, but the question is, do we need some encouragement to drive better BEVs? I've done some analysis, and unfortunately for Europeans, I've had to use US EPA data because actually the US EPA database is the best one for gathering together efficiency numbers. They actually quote them directly. So this is a chart looking at a snapshot from this, which I've stolen from another website, I apologize. But it's looking at a scatter plot of basically range versus battery size. So if you like, diagonal lines on this are efficiency. And they're plotting range in miles versus battery size in kilowatt hours. I will assume for now that that is usable battery size, but we won't get into that debate. But basically, towards the top left is better, towards the bottom right is worse. A bigger battery with shorter range is a bad idea. But what we do need to do is to look at the mile per gallon equivalent, or some sort of equating things to CO2 values. And if we do that, and I hope I've got the mathematics right, there's a number floating around which says that 1 US gallon of gasoline, so around just 3.8 litres of gasoline, contains about 33.7 kilowatt hours of energy. So if you figure all that through, my line says that 100 grams per kilometre of CO2 would equate to the bottom line on this, the dotted line that says 100 gram per kilometre. And that's about 610 watt hours per mile, if you're used to those as metrics for EVs. If you go to a slightly more ambitious line and go the other side of this scatter, the dotted line that goes up on a steeper angle is a line that roughly equates to 30 grams per kilometre of CO2. So obviously well below any current ICE or hybrid vehicle that's on the European market. But it does indicate that across that spread, we could actually see a sliding scale of some sort of either negative, a tax that would be less the further down you go, or even a positive incentive to run vehicles and choose vehicles that are more fuel efficient, more energy efficient. Now, this is only considering the tank to wheel story. If you want to talk about it in ICE terms, this is electricity arriving at the charge plug on the car and being used for motive power. There is a wider story, which is about the grid and the chargers and so on, which I haven't included in here. But it's just a thought to keep in mind, is that we do have an opportunity to not just bring cleaner air by choosing EVs, but if we're to have a proper impact on world energy consumption, wherever it comes from, green or grey or even dirty energy, it will pay us to use less energy for moving ourselves or goods or services around the world. And we should strive to be up into the sort of top right-hand, the top left-hand corner of this graph. So that was a few slides to get us thoughts started. Feel free to weigh in, feel free to agree or disagree during the Q&A session. But the takeaway from this is that I think efficiency is key for going forward. We've cracked getting electric cars out there at all. Now we've got to get more of them out there and get them efficient. So that's me. Thank you.
Thank you. And then Greg, on to you.
Thank you very much.
Greg, I think we've got a little bit of a problem with your audio.
Do you?
Yeah, try again.
Can you hear me now? Very good. My name is Grzegorz Ombach, and I'm working currently at company Dräxlmaier, and we are focusing on producing and responsible for battery systems for electric vehicles and also for plug-in hybrid vehicles, and maybe in the future also fuel cell cars, which also require some batteries. And in a previous role, I had the opportunity working for a company called where I was responsible for the new technology of planning electric vehicles for where we developed charge. And the recent it is the battery for Porsche Taycan. We did it together with Porsche, and it's 800 volt system. And why 800 volt system? Because this battery, the one point is important that the system is going to be high efficient. And you already have heard from David that, for example, the Lucid Air developed a higher train in a very efficient way, and they are using even the higher voltage, or something like, based on the press announcements, more than 900. Therefore, higher voltage, of course, it has the impact. We can definitely use. Also, what is important with the higher voltage, we can definitely use the higher charging rates. And what is very important, especially if you are thinking from the daily use of electric vehicle. And I'm driving electric car, and I had the opportunity using the various cars and also using the car driving to holidays. I'm living in Germany, and then if you are driving, for example, the full days to Italy or France, and you have to drive a couple of 100 kilometers, then the car, which has a range of about 350 kilometers, you have to do a couple of the stops. Therefore, if you do it, then definitely you would like to have a stop which is not longer than 15-20 minutes, because then it's starting to be a little bit painful. Therefore, in order to reach such kind of the charging times, which are 15 minutes or less, you have to get the fast charging. And I had very good experience with charging. On the other hand, definitely is going to have the impact on the battery lifespan. It's not just from the vehicle perspective, but also with the charging in mind. And during my times when I worked for Qualcomm, I spent a lot of time also in Asia, in China particularly, where we develop technology and we work on the standardization, and we work with the major players in China from the charging perspective. And they are, if you are looking on this market, then probably there are two main ones. One is the state-owned state grid, which is always something like 45-50% of the charging infrastructure. Then one is the private one, good, which is owning about 30%. And then there are smaller ones, which is important from China perspective. They had a lot of the problems with some fire hazards during the charge, which is also connected to the entire system monitoring, battery monitoring, and so on. And they introduced something like beginning of this year that they make the joint venture between the different charging providers, and then they are monitoring the data during the charge. And by using the data which car is providing during the charge, we're able to reduce the fire hazards of about 95% during a couple of weeks, which is a huge number. And from this perspective, if we are discussing the electric bus car, mentioned before, there are also other technologies. We are talking about plug-in hybrids, we are talking about the fuel cells, we are talking about batteries. And it's not just vehicles, it's also infrastructure needed to drive those cars. And today we are going to discuss the various aspects of electrification, and I'm really happy to provide my input into it. And even if you are going to look in the latest economics, where the great articles which are describing that it's not just about electrification, it's about the future power. Who is going to have the future power from the perspective of the energy security? Because the oil states are going to the end, and we are going to talk about the electric state. And now, who is going to have the power? We are going to see in electrification. Thank you.
Thank you very much, Greg and David. Yeah, so the great introductions from everybody, I think, is well taken in so many different people's angles as well. So we've got, obviously, Greg, from your side, you know, the work with Porsche, but also the fact, you know, with the Porsche Taycan and the battery system that you guys developed as well, was obviously the first real launch and massive discussion piece around 800 volt, the importance of 800 volt. You know, is 800 volt for performance? Is it for charging? Is it for durability? So, you know, hopefully we'll try and get into a little bit of that earlier on. David, I think David's very interested as well about, you know, starting to really try and understand that is an EV just an EV, or is an EV something more? And how do we, particularly if we really reach out ourselves in the future? One question I think to both of you, and one question that kind of got me started on that presentation was, you know, today as consumers, there's a readily available, you know, pub talk or whatever you will of my car does X miles per gallon, and my car does X per liters per 100 kilometers. We have in the continent, or even kilometers per liter like they have in Japan. What I'd be interested to understand from you guys is, how do you see consumers' understanding of how an electrified vehicle works? Not just from an EV, not just an EV, but, you know, a plug-in hybrid. You know, we have massive CO2 benefits on a WLTP or an EPA cycle, but that's not necessarily reflected in the real world. How do you think consumers are understanding this transition to electrification when they're in their brain think petrol, diesel, miles per gallon? So I kind of question to both of you, how do you think consumer awareness of these technologies is going to drive the future, or maybe cause us issues in the future?
I'll kick off if you want.
Yeah.
I mean, I think we've already got confusion out in the world, and you know, so far the only real metric that people have used, and I think it's evident in marketing of EVs, is that range is all that matters, and that the only number that people will have in their heads, as you say, in the pub conversation, is what range does your EV have. Now, you know, that's a number that typically people who own ICE cars don't even talk about, because, and I would doubt that most people really have much of a clue about range unless they're looking at their trip computers every trip and deciding how far before they have to fill up. But it's the only metric that typically BEV consumers understand. And of course, that's driving the wrong behavior, because that's causing people to buy vehicles with excessively large batteries at the moment, which brings with it all of the issues of, you know, consumption of raw materials and carrying around a load of mass that perhaps is not very effective. I think the EPA has actually taken a pretty strong position on this, and, you know, government consumer labeling driven in North America has actually, after a lot of debate around the mobility community originally, settled on this mile per gallon equivalent number for all non-conventional fuel vehicles. And that really does allow a consumer to have a single number by which to compare conventional ICE with hybridized and BEV solutions, based on the same numbers that I put in my presentation, you know, the equivalent energy value of a litre of fuel, essentially. So that is a very relevant topic. The EPA drive cycle is actually already something that's is much better than the NEDC cycle. It's a much more realistic cycle. perhaps not quite as good as WLTP, and obviously real world are going to change things. But I don't think many American consumers have been particularly disappointed by a range when they buy on the equivalent mile per gallon value that they've had. Going forward, you know, we do have too many units. You're right, Kevin, and that's something we need to simplify. But I would like to see the you know, some labelling that is equivalent to the labelling we've seen in ICE cars. And I think people do understand the grams per kilometre story for of CO2 for ICEs, and they don't see a similar number for BEV. It's just, as I say, it's below 100. Therefore, it's, you know, attracts no tax and attracts some incentives.
If I can then jump on that. Honestly speaking, I think that from the electric
Greg, sorry, Greg, just to let you know, you keep cutting out. I don't know if there's any way, could you join by phone or something? For some reason, you just keep cutting out. I want to make sure you're heard, because I think you've got a lot of interesting things to say. So, yeah, try again and see how we got on.
Can you hear me now better?
Yeah, cool. Keep trying.
I will try. Okay. From the perspective of the electric user car, I think that it's not just about the number, it's what kind of a kilowatt hours per 100 kilometers you are going to use. But this is starting to be a bit more complicated. But that's the point that und
Yeah.
300
Okay.
Something like 50 miles a day or so, then you are forced to come to charge every few days, and or even often if you have the higher ranges. Therefore, as my example is, when I'm driving electric cars, I have drive every day about 100 kilometers one way and another 100 kilometers back. Then it's about 100 kilometers. And now if I have a car with a range of 300 kilometers, this would mean I have to charge every day. And now if it's coming to the point and you have to charge and you don't have the garage, then automatically it's forcing you to thinking about using some infrastructure. And now, once again, I think the combination, having the fast charging capabilities, having some public charging, which is well distributed, is going to be more important than how much we are using for 100 kilometers, which of course has the impact on the battery size, is going to impact on the battery of the vehicle cost. But in general, I think it's a bit more complicated because we have to add additional charge infrastructure, which was not the case in case of the petrol vehicle.
Okay. Yeah, and I think that's one thing from my side. It'd be again good to hear from you guys of that complexity, and I keep trying, you know, revolving always around the customer. As I started this call about, is 96% of vehicles still have an engine, and that means the consumer still has that requirement, desire, need, whatever, depending on which side of the fence you want to sit on, what they have. But how do we as an industry get them in a position to move on to BEV? How do we, you know, get them to understand and make the transition? And also from a gasoline car through maybe a mild, a full or plug-in all the way through to an EV. How do we as an industry help them do that? But second, what do you feel is the importance of some of those powertrains? You know, we're trying here in this topic, it's very challenging. We talk about EV, we talk about powertrain, which are kind of they're now joined at the hip in terms of industries. But where do you think the importance of us as an industry having all these powertrains out there is? Or do you think we should simplify that journey, and as an industry, you know, only offer hybrid, or push away mild hybrid because of some of their inconsistencies? Or how do you think about that? Or do you think we should give the customer the option? Oh, Greg. Greg, your audio's cut out again, unfortunately. I think maybe try, Greg, if you've got some headphones, maybe try that. Dave, if you want to take it.
Can you hear me now? Can you hear me now?
Yeah, I can hear you now. Try that.
Very good. I think if we are looking from the technology perspective, then there is, as we already discussed, we are going to transition from combustion to electric. And now, what you are asking is, do we have to have this transition? Can we make a rapid jump from customer?
Yeah, I think, Greg, unfortunately, I think we may have some technical issues on your side. We try some headphones if possible, but I think it might be your connection as well, just because it keeps jumping in and out from that side. Dave, if you want to take that just in the meantime, if that's all right.
Yeah, sure, Kevin. So you're right. We've created a landscape of powertrain options that is more complicated than anybody could have perhaps imagined, going back a decade or so. Helping consumers to navigate through that has resulted in us having to form quite a lot of alliances across industries, and certainly, the early rollouts of BEVs, for example, which were done with energy companies basically on board to try and bring home charging solutions as part of your purchase package, so that you not only bought the car, but you had an electrician came to your house to put the charge, the wall box onto your house, and no doubt relieve you of some money to upgrade your electrical connection while they were at it. That's been there all the time. We've also had these extremely complex arrangements for how you go and get access to public charge points. The fact that you had to, in some cases, have a great long string of access cards and passwords and PIN codes to allow you to access different networks. I think there is slowly, coming some transparency on it, but it's the equivalent of, buying an ICE car and only being able to go to a Shell fuel station to plug it in, not to a BP one or anything else. So we do have to make the access barriers go away. But in terms of the choices of which is the best car for me, I think there is some clarity that I think is getting couched in public terms now, of people realizing that things like plug-in hybrids are very good if you've got a journey pattern that requires you to drive long distances fairly frequently, but you still want a zero emission short range vehicle. And I think that's one of the reasons why PHEVs, which on the face of it are one of the most complicated technologies, because they combine almost full power BEV with full power ICE and lots of complexity and a decent battery size. It's why they're getting some traction, because they do solve the assumed problem for most people. But what I do think we've got to do is help people, and particularly post-COVID, where we've realized that our journey distances can be significantly shorter than our vehicle use can be considerably less than we thought it would be, is to encourage people to make a green choice and to actually adopt the minimum amount of car they need for their real lifestyle, as opposed to the maximum amount of car they might need for some imaginary way of using it. And how that happens, I mean, it's only through consumer bodies getting correctly informed, but particularly it's about dealers being open and honest with customers, of actually steering them away from the wrong car in the showroom and lining them up to the car that's right. And I think some of the initiatives, for example, here in the UK again, the OLEV have sponsored this EV Experience Centre, which there's certainly one in Milton Keynes. I'm not sure if there are others now, which are non-partisan, non-branded locations where you can go and talk to somebody about EVs and electrified vehicles generally, experience some cars, but also get a neutral opinion on what's the right car for you. And I think although that is it's a marketing cost that somebody's got to bear, it really will help to increase satisfaction with people's purchase decision.
And I don't know if you can hear me now better.
Yeah, let's try again. Yeah, let's keep trying.
Let's keep trying. Sorry guys for this synergy with connection. Sometimes it happens. I fully agree. I fully agree with David on the aspects if you are looking from the customer perspective and various technologies. What we should also keep in mind is that we are not going to have the electric vehicles during the one day on the one. It's going to be a process which is going to take not just 1 decade. It's going to take something like 2-3 decades to reach the point. And it is even more complicated because we are not just talking about the changes which are currently happening in automotive business, where we are talking about the moving from internal combustion engine towards more electrified and pure electric vehicle at the end of the day. But we also see the similar changes which are happening today in the area of the infrastructure, on the infrastructure side. It means if you are looking what is happening with all renewable energy sources, how this is changing also the way how we are going to generate electric energy and how this electric energy is going to be distributed. We are also going more to the edge. And then if you are going more to the edge and if you are thinking about the people which have their own storage of energy of in private homes or in the small business, then this definitely can be reused later on, for example, to charge electric vehicles. Therefore, I think it is more complicated just looking on the automotive. It is the entire world is currently changing, moving from this petrol state in direction of the electro state. And if by this movement we are moving also and distributing the power in direction of the users and customers. And this is going to have an impact on the choice what the customers are going to do. Because if you are owning the own home and you have a solar panels on the roof, and you have a storage in your garage, I don't know, 10 kilowatt hours or similar, then definitely you are going to have a different requirement for buying electric cars compared to somebody who is living in the condominium and doesn't have access to the private charging spot. Then definitely this person is going to require a much bigger range and probably going once a week to the fast charging station to charge the car. And there are already many programs on the way looking after creating such kind of a fast charging opportunities for such kind of the users. Therefore, I think it is not just answer everything go in one direction. We are going to need the various technologies, and we are going to have also the various ranges of the electric cars because they are going to be different users, dependent not just on the habits and the requirements, but also on the context in which these users are going to use those cars. It means are they have a private home? Are they going to live in condominiums, and so
on? If it's okay to push forward a question, this one is in regards to Lucid Air. Is miniaturization the way forward, or should we expect vehicle efficiency to come more from improvements in batteries and chemistry?
I think if you are looking on the, as already David mentioned before, on the Lucid, this guy did fantastic work on the optimizing the entire system. It means if you are looking, they're not just focused on optimizing the system. What they did, they look on the entire powertrain from the electric engine over the gearbox, over the power conversion and battery going with the higher voltages and so on. And also on from the charging perspective, looking after optimizing the charging experience and efficiency, and also going into the vehicle architecture as such and optimize the factor of the car. And
I think we've lost Greg again, but if I can come in with a separate question. Does the panel think fuel cells will play a significant role in the sustainable transport, or is it if and when the energy density of the batteries reach a threshold, does hydrogen largely become irrelevant? What do you think, Kevin?
Yeah, so this is a bit of a controversial side. I wonder if my boss is listening in for this one, or maybe even he proposed it. From our perspective and the work that we've done, and we've had calls with even government officials on this. Within the passenger sector, passenger vehicles, in the vast majority of those cases, the boat has already sailed for fuel cell. If we're really being honest about the capability of fuel cell to make a lasting impact, people talk about when BEV gets cost parity, when BEV batteries get more production, when BEV becomes more energy dense or power dense. Or that point doesn't matter. Really, the use case, the customer, the fueling, the infrastructure investment, the requirement for more than a 300, 400 kilometer electric vehicle just starts to disappear when you get more customers into the situation. So from a passenger car side, fuel cell really does have a struggle. Obviously, we've had the recent announcements from JLR that they're looking for their ones, but that's a large vehicle mass. And again, they're going to have difficulties with launching because of infrastructure. If we move on to commercial vehicles, particularly heavy-duty commercial vehicles, the dynamic is considerably different. There, the loading capacity of the vehicle is critically important. You don't want to weigh up with batteries. You want to have that as clean as possible. Their route planning is highly defined, particularly around freeways and motorways, where we can centralize a few specific hydrogen infrastructure situations on motorways. There is a huge business case for that. Obviously, we've seen the announcements from Volvo and Mercedes-Benz around their joint partnership, with Mercedes-Benz only this week or last week releasing their vehicles. And obviously we have Nikola in the US, who has their trucks and their partnership with Iveco in Italy. So I think that's really where hydrogen is going to be success. Elsewhere, no, not really. I don't know, Dave, if you agree or not.
Yeah, I mean, hydrogen is as a total topic is interesting, and the renewed interest in hydrogen after spending the last 40 or 50 years thinking about hydrogen as a transport fuel. I think it suggests that there must be something in there, otherwise we wouldn't be throwing good money after bad when it comes to researching it. And things like the California Fuel Cell Partnership did indicate that if you put suitably spaced infrastructure in place, you can actually convert people to hydrogen fuel cell vehicles fairly easily. But I would completely agree with you that the light duty automotive applications are actually only going to be in the heavy end, because the chemistry set and the storage and so on, the overhead is something that's too difficult to do in smaller cars. But for long haul vehicles, I fully agree with you that the route planning is going to be the key, and the ability, just as we did with EVs in the early days, the ability to put charge points, refueling stations at suitable locations will help you, and the fact that you realistically can create 1,000-kilometer vehicles. Science. It isn't something that you don't need cryogenic tanks and all the other things to get a decent range, and I think that will ultimately mean that the commercial vehicle users will have a route forward, and they will bring with them the fuel system partners that they need to do it. We've had very good indications from all of the major oil companies that they are definitely keen on hydrogen. And I mean, I remember probably over 30 years ago sitting next to a BP guy at a conference where he was saying we would be quite open to becoming, British Hydrogen, not British Petroleum at the time. But how do we transport the material around to our fuel stations? Where's the national, international pipelines to move this rather tricky gas that sneaks out through any small hole you leave it? So, I mean, I think there is a hydrogen future, but I think it's going to be very selective in terms of its placement.
Yeah.
Inductive charging. Is it like?
Induction charging. Induction charging is one of those things that I think for many years people have thought would be a fantastic thing just from an ease of use situation. What we are starting to see, particularly with the market deployments of it, whether that's through, likes of BMW, who have it in the 7 Series PHEV model, and also Momentum Dynamics, who are, the global leader in that type of solution, we can see the technologies there, but the route to market is very unusual and different for that. We think of induction charging as a way, particularly as a consumer, to have a benefit. You know, you have it on your driveway, you have it in your garage, the car automatically charges. That isn't actually a strong business case for that product, because the customer might be charging the car once a week. What is the autonomous charging doing? Actually, where there's more interesting deployments of it is in places like multi-story car parks, where the infrastructure required to put large stations between car parking spaces, to have the space for the cabling, to have the safety requirements of somebody possibly cutting or tripping that cable, is quite negative. So actually having induction charging in some of these situations, curbside charging where we don't have to have cables creped across pathways, those are actually starting to become quite interesting topics for induction charging, and actually more of a route to market than what we previously seen. I don't think we'll see induction charging on that kind of scale beyond a trial for the next 10 to 15 years, but it is definitely an area where we could see it in particularly urban environments being a use case. And maybe when we try and transit it into you know, things like Ubers or car sharing programs, there is definitely a route to market where they can establish some cost, but maybe not within the next 10 years or so. Oh, Peter, I can't hear you. Now you're on mute.
I'm just going to say, have you any thoughts, David, on that?
Yeah, I mean, I think, you know, there have been a number of cases. We should also separate as well dynamic induction charging from static. I think there's two, you know, the whole connected road story where we're picking up charge as we drive along, I think has got a larger element of fantasy to it, just because the amount of copper you need to bury in the ground is quite significant. But for fleets, and I think, you know, Kevin, you mentioned this with you know, with taxi fleets, for example. I think there is a good use case, and one of the, you know, the momentum dynamics cases you mentioned, you know, with bus operators, where they can, you know, during the few minutes they're stationary picking up passengers, they can take on a useful amount of charge at each bus stop, and avoid any more invasive infrastructure going in, like pantographs or any of the other, you know, short-term solutions. So I think those, you know, it's a little bit like the hydrogen story in some ways. If you can bring your own special way of using the charging network, then inductive charging does have some advantage. And as you say, the trip hazards of you know, cables, particularly the cables required for high power charging, which are not light, it does have some major advantages. But it's got, you know, you've got to get interoperability first of all, so you've got to have agreed standards, and, you know, the high capital cost of the fixed infrastructure is significant, as well as putting yet another expensive piece onto a BEV, which is already struggling to make a business case with the hardware you have to put on it today. So tricky use case.
I don't know. Can you hear me guys now?
Yep, let's try again. Yeah.
Let's again. Yes, so again. Yeah, we have challenges here with network. Well, the point is the following: that if we are looking on the inductive charging, exactly depends on the use case scenario. Then there could be some scenarios where definitely it makes sense to apply it immediately. There are some other cases where you have to postpone it in time. And from the standardization perspective, work has been done over the last couple of years, and we have the final standard in China.
Sorry, Greg, you've gone again. But we are very close to sort of time now. One, if we could, just as a wrap up, and thank you for sort of going through this, and we could have run on for a lot longer because we've not covered all the bits and bobs that we've had in. But from a perspective moving forward, is there anything that you'd like to leave as a short sort of takeaway statement for everyone? David.
Thanks for putting me on the spot first, Peter. No, I think. Okay, well, there we go. Yeah, I think after such a long struggle to get electrification into people's minds, You know, I'm very relieved that the world post-COVID appears to be the stimulus to take it, you know, much more seriously. As you know, Kevin's numbers indicated at the beginning, the uptake of EV in the new world appears to suddenly have taken that step forward. It's still a long way down. It still needs much more work, but it is coming. But I do think that that we as an industry owe consumers this, you know, this story we've been talking about. We have to be better at educating, and that's one thing, particularly in our own home market of India, that we've had to put a massive amount of effort. Some of it looks like PR, some of it looks like customer relations. You know, there's a fine dividing line, but we've got to just educate, and of course use events like this to flush out the you know, what the hot topics of the day are. But the rewards of cleaner air and lower energy use are definitely worth having. I think we all know that.
Thank you. And Kevin, we've got a minute before they probably cut me off.
Yeah, no problem. What's quite interesting is, Dave, you took my point. You stole my point. As I commented on I think all of our good friend Graham Cooper, who's, you know, an amazing guy to know in this industry as well. He put some things on LinkedIn this week, and I commented the exact same comment. You know, we as an industry are full of mega intelligent people throughout the entire, you know, engineering, sales and marketing, systems, strategy, corporate strategy. But the one thing I feel that we are lacking in this transition to zero emissions and low carbon is education of the consumer. And we are actually, in the push of electrification, we're actually, I think, driving confusion through the consumer, and the consumer will always default back to, what do I know best? So I'll pick up a petrol car. Okay, I shouldn't buy diesel anymore, so I'll buy a petrol. That's why CAFE compliance numbers have went up this year, not down like the regulation requires, but up. And I think we have to understand it. And I think as an industry, we're starting to fail at that. We've been good for a couple of years. We're starting to see, you know, sorry to all the people out there who may drive Toyotas and Lexus, but, you know, self-charging hybrids as a marketing technique only further confuses consumers who think they're buying a green vehicle with a petrol engine driving it. Or even, as we've seen from Ford recently, come and buy your hybrid Ford Kuga and hybrid Puma, and it's a larger alternator in the form of mild hybridization. I think we really need to start, as an industry, educating our consumers better on what those are, how to use them, and if you have a PHEV, what is that PHEV? How do you use it? But not in generic speak as engineers of, here's 16.4 kilowatt hour of battery, you can get 45 kilometers of range on a WLTP warm cycle with your AC off, but more, what is your drive cycle? How do you use a car? Here's the best for you. And I think that's what we are missing.
Sorry, thanks very much. Really appreciate it. And sorry, we're sort of, I'm being rushed to go. Take care. Speak to you soon. Bye.
Thank you very much. Bye.
Thank you very much.